Welcome to today's video. Today we'll be talking about solving system of equations. If you remember, system of equations are usually a set of linear equations that have more than two variables in them. Usually the simplest ones have two. And so in this case, x and y, which we have no idea what the value of x or y is, so we have to solve them by using either the elimination method, the substitution method, or the setting them equal method, I guess you would call it. So we'll start with the substitution method. The substitution method is basically where you pick a variable and solve for that variable in one equation. So I like to solve for y. So we'll just use the first top equation. So we have 2x plus 2y equals 8. So we'll solve for y. So we minus a 2x to both sides, because what we do on one side we have to do to the other. We get 2y equals negative 2x plus 8. Now we divide by 2. We have to divide everything on this side by 2. And then you get get y equals negative x plus 4. Now we can plug this back into the y in the other equation. So we have 5x minus 6 times this, which is negative x plus 4, now equals 13. Now we can distribute. So we still have 5x. The negative 6 times the negative x makes a positive 6x. Negative 6 times 4 is a negative 24. Equals 13. Now we'll combine like terms. 5 and 6 is 11x minus 24 equals 13. To get x by itself, we'll add 24 to both sides, and we get 11x equals 37. Then we divide by 11, and we get x equals 37 elevenths. Or, if we plug this into our calculator, if you want to know the decimal value for it, it's 3.36 repeating. So if you looked on a graph of these two, that would be the x-intercept for that. Now, knowing that, we can go up to either equation. I'll just use the first one because 2 seems like a decent number to deal with. And now we plug in x for x, so we get 2 times 37 over 11 plus 2y equals 8. So now we get combine these terms, multiply this out, we get 2 times 37 is 74 elevenths plus 2y equals 8. Now you subtract 74 elevenths to both sides, and you get I'm going to just convert this into a fraction. So we get this is equal to, right here is equal to 88 over 11. So you get 88 elevenths minus 74 elevenths, and you get 14th elevenths. So 2y equals 14 elevenths divided by 2 divided by 2. In this case, you'd multiply by the reciprocal, which would be 14 elevenths times 1/2, and you get y equals 14 times 1 is 14. 11 times 2 is 22. So 14/22, or approximately equals, technically that would be approximately equals, because it's rounded, 0.63 repeating. So if you take your calculator and you get in, which you can't because it's not in y equals form, so that would be the same thing there. So we'll do the same thing with elimination. So for example, on elimination, let's just say we're still given, we have 4x plus 5y equals 8 minus 4x plus 6y equals 14. So elimination, if you have one that has the same coefficient in front of the x, but it's the opposite sign, you can basically do addition or subtraction depending upon what you have. Like if you had the exact opposite, and to say 4x plus 5, y equals 8, and 4x plus 8y equals 14, then you could do subtraction that cancels that out. In this case, you can add and now cancel that out, and so 5 plus 6 is 11y. 8 plus 14 is 22. Well, that's pretty convenient. Now we can divide by 11 on both sides, and we get y equals 2. Now, since we know y on one of these, you can plug it into either equation. Either will work. And you'll get, we'll do the top one. 4 times x plus 5 times 2 equals 8. So 5 times 2 is 10, plus 4x equals 8. Subtract 10 to both sides. 4x equals negative 2. Divided by 4, x equals 1/2. And basically, you can plug it into this one. Negative 4 times a negative half gives you a positive 2. And so that's 2. And 6 times 2 is 12. So 2 plus 12 is 14. So that works. Now, if you want to do this one, we can do this one. And we have that zeros out, and you get 13y equals 22. Divide by 13. So y equals 22 over 13. Now we know that. We can plug it in. We'll just do, let's just do 5. So 5 times 22 over 13 gives you So 4x plus 5 times 22 over 13 equals 8. Gives you 110 over 13. That's a very ugly number, but it'll work. Equals 8. You subtract from both sides. 110 over 13. So you take 110 divided by 13. Or 8 minus 110 over 13. And you get negative 6/13 on this side equals 4 divided by 4 by 4, which is the same as multiplying by 1/4, and x equals 13 times 4 is what? Negative 6 over 52. So that's basically the elimination method. Now, my personal favorite is, let's say, for example, we have 4x plus 6y equals 12, and 2x plus y equals 4. So my personal favorite is if you can get them in common terms, you can set them equal to each other. I like to call it the equal equation method or the equal value method. I don't know if that's the correct term, but I like to call it that because what we're going to do is solve for, I like solving for y because most graphs are in y equals form. So let's take, for example, for x minus 6 or plus 6y equals 12. You minus the 4x to both sides. You get 6y equals negative 4x plus 12 divided by 6. You get y equals 4 divided by 6 is, you can simplify that down to negative 2/3 plus 12 divided by 6 is 2. So that's that one. And then this one's pretty simple to solve. You just minus the 2x from this side. On that side you get y equals negative 2x plus 4. Now since they're both equal to y, you can set them equal to each other because this equals y and that equals y, and both the y's are the same. So you can do negative 2x plus 4, which is equal now to negative 2/3 plus 2. Can't forget my x there. So now we can solve for x. Let's go minus a 2 there, minus a 2 there. Negative 2x plus 2 equals negative 2/3. Add 2 there. X. Add 2x there. What is, okay, negative 2/3 plus 2 is 1 1/3, which is 4/3. Okay, yeah, that's right. Because that'd be 6/3 minus 2/3 is 4/3. There we go. So 2 equals 4/3 x. Now, divide by 4/3, or I like to do times by 4/3 x times 3/4, because that cancels out. So 2 times 3/4, that's over 1. 6/4, or 3/2 equals x. So now, knowing that, we'll plug it back into, we'll just plug it back into the bottom one because that'll go in good. 2 times 3 halves plus y equals 4. So 2 times 3 is 6, divided by 2 is just 3, so that cancels that out, and that becomes 3 plus y. And now what does 3 plus y equals 4? You can solve from minus 4, y equals 1. So the coordinates, or the value would be x equals 3 halves, y equals 1. You could check that on any of them by plugging in the x and y values back into each of the equations, and if they equal the number on the other side of the equal sign, because the values for x and y added to each other will equal the value on the opposite side. So it's a true statement on all of these. So in conclusion, the 3 methods for solving system equations to find the value of intersection or to find the values of x and y, in which will be the same for both equations. You can use the substitution method by turning 1 into a y equals equation or an x equals equation, then plugging it into the y portion of the equation, or the x portion of the equation will also work. Second, you can use the elimination method if you have a equation in which it has a same coefficient in front of the variable, but it has a negative sign out in front of it, or has the same sign as it. You can either add or subtract the equation, and you can add these and add these, or subtract these and subtract these, and solve for y, then plug it back into one of the equations to get your other variable. That is an also acceptable way, and or the equal values where you have 2 equations, you set them equal to y or x, solve for the one variable, plug it back in for the other, and find your x and y variables. I hope this was helpful. If you wouldn't mind liking this video, comment down below on any other videos that you'd like me to post, and I'll see you next time.